Simultaneous Occurrence of Events. Welcome, everyone. Today we are going to dive into a very important concept in probability. Now, up until this point, you might have been focusing on the likelihood of a single, isolated event happening. However, in the real world, we often encounter much more complex situations. We aren't just interested in one thing happening. Instead, we frequently find ourselves looking at scenarios where we want to know the probability of two or more different events happening at the exact same time. When we are looking for this specific overlap, where multiple conditions are met at once, we refer to this as the simultaneous occurrence of events. Over the next few slides, we will break down exactly what this means mathematically and how you can identify it in practice. Understanding the concept. Now that we have introduced the topic, let's dive deeper into understanding the concept itself. When we discuss the simultaneous occurrence of two events, which we will call event E and event F, what we are really talking about is a scenario where both events happen at the same time. It is very important to note that it is not enough for just event E to occur, and it is certainly not enough for just event F to occur. For us to say that a simultaneous occurrence has actually taken place, both conditions must be satisfied simultaneously. If you are looking for a way to remember this, think of it in logical terms. This concept corresponds directly to the word and. To make this even clearer, let's look at a real-world example. Imagine you are searching for a specific person in a large group. If you are looking for someone who is both a student and an athlete, you aren't just looking for any student, and you aren't just looking for any athlete. You are specifically looking for the simultaneous occurrence of these two characteristics in one single person. In the next slide, I will show you how we write this down using mathematical notation. Mathematical notation. Now that we have established the conceptual meaning of simultaneous occurrence as the and condition, let's look at how we actually write this down in a mathematical language. To represent this simultaneous occurrence of events mathematically, we use a concept you might already be familiar with from your set theory lessons, the concept of set intersection. If we have two events, let's call them E and F, which are both associated with a larger sample space, which we denote as S. The specific event where both E and F occur can be written in two different ways. First, we can use the intersection symbol. Writing it as E intersection F second, you will often see a much quicker, shorthand notation used in probability textbooks, where we simply write the two letters together as EF. It is very important to remember that both of these notations, E intersection F and EF, represent the exact same event. They both refer to the set of all outcomes that are common to both event E and event F. In the next few slides, we are going to use this notation to walk through a practical example involving a deck of cards to see this in action. Step-by-step illustration with a real-world example. Now that we have established the mathematical notation for intersection, let's move from theory to practice. To better understand how this works in a real-world scenario, let us consider a standard deck of 52 playing cards. Our specific scenario is this. We want to find the probability of an event where a single card drawn from the deck is both red and a king. To solve this, we will break it down into clear steps. In step 1, we must first define our sample space, which we denote with a capital S in this particular experiment. The sample space S consists of all 52 cards present in the deck. Next, in step 2, we define our first individual event, which we will call event E. Let event E be the event that the card drawn is red. If we look at the composition of the deck, event E includes all hearts and all diamonds. Since there are 13 cards in each of these two suits, the total number of outcomes in event E is 26. Step-by-step illustration with a real-world example, continued. Now that we have defined our first event, let's move on to step 3, where we define event F. In this scenario, let's say event F is the event where the card drawn is a king. If we look at a standard deck, this event includes the king of hearts, the king of diamonds, the king of spades, and the king of clubs. So the total number of outcomes in event F is 4. This brings us to the most important part, step 4, where we identify the simultaneous occurrence, which we write as E intersection F, or simply as EF. To find this, we are looking for the outcomes that belong to both event E and event F at the same time. Remember from our previous slide that event E was all red cards. So, we are specifically looking for cards that are both red and kings. When we look at our two lists, the only cards that satisfy both conditions are the King of Hearts and the King of Diamonds. Therefore, E intersection F equals the set containing the King of Hearts and the King of Diamonds. As you can see, the simultaneous occurrence is represented by just those two red kings in the deck. This perfectly illustrates how the intersection narrows our focus down to only the outcomes that meet every single condition we've set. Key takeaways. First, let's revisit the core definition: simultaneous occurrence. As we discussed earlier, this refers specifically to the scenario where two or more events happen at the same time, or more precisely, where both required conditions are met within a single trial. To help you identify this in word problems, remember the logical operator. Whenever you see the word "and" used to connect two conditions, you are dealing with a simultaneous occurrence. This is the key linguistic clue to look for. Now, regarding the mathematical notation, there are two ways you will see this written. You can use the intersection symbol, which is written as E intersection F, or you can use the shorthand notation, which is simply writing the two events together as EF. Both of these represent the exact same concept. Finally, it is important to remember the connection to set theory. As we saw in our card example, the simultaneous occurrence of events is mathematically equivalent to the intersection of the sets that represent those events. It is simply the collection of all outcomes that are common to both groups. All right, let's take a moment to recap everything we have covered in this lesson so that you have a clear summary to study from. Now, before we wrap up, I want to point out a few common pitfalls that students often encounter, so please pay close attention to the next slide. Common mistakes to avoid. First, a very common mistake is confusing the intersection symbol with the union symbol. You might see the symbol E intersection F and accidentally treat it as E union F. Please be careful here. As we discussed in the previous slides, the intersection, which is E intersection F, specifically means that both events must happen. Think of the word "and." On the other hand, the union, written as E union F, means that either event E or event F, or even both, must happen. This is associated with the word "or." To keep your calculations on track, always remember that whenever you see the word simultaneous, it is a direct signal to use the intersection symbol. Secondly, there is a slight nuance in how we interpret the word simultaneous that can be confusing. In probability, simultaneous doesn't necessarily mean that two separate actions are occurring at the exact same microsecond. Instead, it means that within a single trial or a single observation, both characteristics are present. Let's look back at our card example from earlier. When we looked for a card that was both red and a king, we weren't performing two different actions. We were looking at one single card and observing two properties at once: its color and its rank. That is what we mean by simultaneous occurrence in this context. Now, before we wrap up today's lesson, I want to touch on some common pitfalls that students often encounter when studying simultaneous events. It is very important to keep these in mind to ensure your logic remains sound. If you can keep these distinctions clear, you will have a much stronger foundation for the more complex probability problems we will tackle in our next session.